So friends, what we have seen is evolution of the 7-layer model of OSI. So while doing so, we have seen initially only 1-layer model. Then we have seen how the work can be categorized into 2-layer models. Ultimately, we have seen 4-layer models, 5-layer models, 6-layer models, and now we are coming to 7-layer models. So if you see the evolution of the entire process, then you will see that there is a lot of standardization of notations or syntax for application messages. So that is called as abstract syntax. And there are a lot of set of encoding rules per model. So that's the very important thing about the OSI layer. So here you can see that the 7-layer model, which you can see on the screen, it consists of 7 layers right from the physical layer to application layer. So if you just go through, the first layer is physical layer, second is data link layer, third is network layer, transport layer, session layer, presentation layer, and then application layer. As we have seen, each and every layer has to do a specific task. Each and every layer has to work with other layers, the layer above it and the layer below it. Each and every layer is the counterpart on the other side. That means the transmitting machine and the reception machines. The layer will talk to each other. So therefore, the name of the model or the functionality of the model is expressed as peer-to-peer communication. So peer-to-peer communication is the basic of this 7-layer model. And ultimately, what benefits we are getting using these 7-layer models? The first benefit that we get by using 7-layer models is that it breaks down the communication into smaller and simpler parts. So many processes are involved in transmission and reception, and it's very much essential from diagnostic point of view, and even for writing the software point of view, writing the protocols point of view, that these processes must be divided into smaller parts, simpler parts, so that every process, every thread can be coded into software. And that essentially has been done by using the OSI reference model, because it divides the entire process into smaller parts, simpler steps. Each step can be coded. Each step can be taken into consideration while designing the hardware. Each step, while doing so, it just gives us the compatibility over the globe. So in this way, apart from the simplicity, apart from the coding point of view, the compatibility, the uniformity is very, very important as far as this 7-layer OSI model is concerned. As you must have seen that I have been teaching this particular model, so it's very easy to teach communication process. Otherwise, there are so many processes involved that it becomes very, very complicated to teach this particular model. The third benefit is that it speeds up the development. Changes in one layer does not affect how the other levels works. So what we have done is, by the way of OSI model, all the steps confining to one layer, they have been identified and they confine to that particular layer. So if you want to speed up the development, you can concentrate the development of in pertaining to that particular layer, so that the functionality and other layers, they becomes unaffected. However, of late there have been merging of these layers. So with the progress in micro miniaturization, or with the progress in the VLSI design technology, now the models, the layers, they have been merged, and a single hardware device is taking care of 2 or 3 layers. Okay, that is happening, or the software is also taking care of 2 or 3 layers. And therefore, one of the aspect of this model is also it's an open model. That is also another important thing. Standardization across manufacturers. As I mentioned this, so it allows you to design the hardware devices which will be standardized, though the vendors are different. So you know that today we have a range of vendors, like Cisco is there, D-Link is there, so many vendors are there. However, if you have a layer 3 switch of Cisco, the layer of 3 of switch of Cisco will do the same thing will have the same functionality as far as the layer 3 switch off D-Link is concerned. So there is a lot of standardization, and that is possible by designing this OSI model. Another thing is allows different hardware and software to work together. So the new concept in this networking is the hardware software co-design, and in order to accomplish the entire communication process, the hardware and software has to work each other in a very cooperative manner, in a very agile manner. So this modeling, the concept of modeling, it allows different hardware and software to work together, because everything has been simplified, everything has been categorized, and therefore it becomes very easy to design the devices. It becomes very easy to code the things. Coding is possible, writing the device drivers is possible, taking care of the functionality of each layer is possible, and in this way it reduces the complexity. It's another aspect of the 7-layer OSI model. So in brief, this is the essence why the OSI model has been developed by the manufacturer way back in 1980s. However, as I mentioned, that over the period of time, like 3 decades, lot of progress in hardware and software has happened, and therefore most of these devices, they now have the functionality which is the merged functionality of multiple layers of the OSI reference model. And for that reason, this model is also called as open model, because it is, you can just modify the things. And of course there are standardization bodies like IEEE, so they take care of the standardization of this particular model. Coming to now the actual functionality of the model, we have seen that this is a 7-layer model, and now we'll see that what each layer is doing in this particular model. So the layer number 1 is the physical layer, which is the bottommost layer in this model. So what this layer is doing is the actual transmission, the binary transmission. So we have seen that the actual transmission, like the specifications regarding the voltages per bit, or the current levels, or the data rates, the signal to noise ratio, so everything is being handled by the physical layer, because it is just responsible for the binary transmission. So wires, connectors, there are so many kinds of connectors are there depending on the media. So all those things, they are taken care at the physical layer. So physical layer is responsible for binary transmission. The layer which is just above physical layer is the data link layer. So data link layer is roughly responsible for access to media, right? So media comes at the bottom, and the layer just above the physical layer is responsible for giving access to the media. The network layer, the third layer, is responsible for giving the addresses and finding out the best path. We know that on internet there are so many machines, millions of machines are there, billions of machines are there, billions of nodes are there. So every node must have a unique address, so that it's identifiable, it can be identified, so that who is the transmitter and who is the receiver, from where the data is originating and where the data is to be dispatched. All these things needs to be noted down and needs to be taken care. So network layer will be doing this particular work. First of all, it is giving addresses, and the second thing is, since the data is transmitted from the transmitter and receiver, and there exist so many alternate paths, so which is the best path as far as the timing is concerned, which is the best path as far as the congestion is concerned. So all those things, the functionality is belongs to the network layer. Above the network layer is the transport layer. So transport layer is responsible for end-to-end connections. So from transmitter to receiver, all the end-to-end connections are handled by the transport layer. The layer above the transport layer is the session layer. Session layer is responsible for inter-host communication. So when the data communication starts, a particular process starts, then it is a session which is commencing. So commencing of the session and termination of the session is very important. Otherwise, if this doesn't done properly, then there will be a lot of congestion, because the session commencing and termination, and then the approximate estimate how much of the time the data transmission will be taken place. So all those things the estimation and other parts, the QoS. So entire thing will be handled by the session layer. Then comes the presentation layer. The presentation layer is the entirely responsible for data representation, because data can be represented in so many systems. ASCII is there for representation, while actual data transmission is done in binary. So all that conversion part is taken care by the presentation layer, so that presentability of the data is taken care. And then the last is application part, which gives the access to the user. So in short, the network processes to application mapping is done by the application layer. So this is the layer with which the user is interacting, and it's the layer that gives services to the user. So in this manner, all these 7 layers, as I mentioned in last video or even in this video, that they don't work in isolation. Every layer has to have some interface with the layer just above it or the layer just below it. Every layer has got a certain functionality. That functionality is taken care either in hardware or in software, or in both hardware and software. Every layer has got some processes that has to be accomplished, so that the entire data communication can be taken care in a very smooth and hassle-free manner. And overall, all this 7-layer model, in this way, it takes care of the quality of service, it takes care of the smooth handling of the data transmission and reception process. It divides the entire data transmission and reception process in very, very simple steps, so that those steps can be further converted into hardware design and software design. And in this way, the hardware software co-design is even possible. Of course, we'll be going into the depth of each and every layer, but this is for the time being, this is the summary of what we discussed so far in the OSI model.